Hey there, Mustangs. Welcome back to another edition of No Here, No Problem. Rosenwald here, working with our Unit 3 Radicals test review. This is going to be the one that we're dealing with coming up here shortly on radicals. So let's jump right in. I'm going to work through all 15 of the problems on this review. If I go at a fast pace, that's okay. Just go back, watch it again, try to make sense of everything that you missed, and make sure that you know how to do all the questions from this, because if you could do these, you're in good shape for the test, okay? So let's jump right in. With the first question we're looking at here, we're looking at taking 6 times the square root of 98, and we're looking to reduce it by using any of the perfect squares that are out there and see if they're the factors of 98. And so recall that the perfect squares that we're using are 4, 9, 16, 25, 36, and so on. Remember, these come from 2 times 2, 3 times 3, 4 times 4, 5 times 5, and so on and so forth, up to 11 times 11. When we're looking at 98, 98 can get broken into two different numbers, okay? What we're seeing is, can I take 98 and divide it by 81? Can I take 98 and divide it by 64? Can I take 98 and divide it by 49? And the answer for that one is yes. I could break it into 49 and 2. The 6 doesn't do anything at this moment. It's just sitting there outside doing absolutely nothing. So let's just keep the 6 out there. So let's go part by part here. First, let's deal with the square root of 49 right here. Square root of 49 is just 7. And the 2, we can't do the square root of 2, so it just stays inside as a square root of 2. The 6, like before, just kind of comes down and gets carried through. So now anything that's on the outside, we can go ahead and multiply those together, so that 6 times 7 that we have right here is going to turn into a 42, and the root 2 just stays on the inside. And that's it. You're done. All right, let's take a look at number 2. Number 2 is a little bit different. This one's dealing with, when we look at this is dealing with cubics, not squares. So remember, when we're looking at cubics, those numbers are 8, 27, 64, and one of them got deleted here on accident. And then the other number on there, it should be 125, okay? And so the way that we derive all of these numbers is, if you recall, you just go 1 times 1 times 1 times 1, which is just 1, 2 times 2 times 2, 3 times 3 times 3, and so on and so forth. The difference, with cubics is that you can end up with negative numbers. The reason being is that if I was to go negative 2 times negative 2 times negative 2, that's going to equal negative 8. If I did negative 3 times negative 3 times negative 3, we can get negative 27. And so when we look at this, there's a negative in here, which tells us we're going to have a negative be part of our problem. So we are asking ourselves, what numbers can I take 56 and divide it by? Well, if I do 56 divided by 27, that just doesn't work. It's just too big. 27 times 2 is 54. So then let's try 8. 56 divided by 8 turns into 8 and 7. Now, I use the negative on the 8 because we just set up here that I can do the cube root of negative 8. The cube root of negative 8 would just be a negative 2. Sorry, I put the 5 out there because, again, we haven't done anything with it yet. The 7 that's right here, we can't do anything with it, so it just stays on the inside. And then the 5 comes down. And then from here, we can go ahead and finish up the problem by putting things together. These are going to turn into a negative 10, and then we're going to have a cube root of 7. And that's it. You're done. All right, number 3. So with number 3, this is the one where you have a binomial times a binomial. And when we say a binomial times a binomial, that's because we have 1, 2. There's 2 terms there, so we call that a binomial, because bi meaning 2. And same thing with the other one, we have 2 terms there. So if we're going to go through and multiply these together, we should go through and FOIL all of this out. Now, I know everybody likes to do FOIL, and I encourage you guys to do it, but I also encourage you guys to use a little organizational chart like what we've got here. So recall, again, that when we're doing these, square root of 2 times square root of 2 is equal to 2. Root 3 times root 3 is just 3. Root 4 times root 4 is just 4. And root x times root x is just x. So the radicals always just go ahead and, like, whatever you have multiplied by itself just equals the number that we had. Okay? So if I was to take this binomial and write it out on here, we would have, we would have a 5 and a negative 2 root 5. If I took the other one, the 4 and the plus root 3, 3 root 5, and we said, let's go ahead and multiply this up, okay? So let's focus on just the 4 first. If I take the 4 and I multiply 4 times 5 and 4 times negative 2 root 5, 4 times 5 gives us a 20. And then 4 times negative 2 root 5 gives us that negative 8 root 5. That's just distributing it to everything. That's the same as if we took that 4 and distributed it to all the stuff that's right here. Okay. The next value we're going to distribute is going to be this positive 3 root 5. Okay, so now let's multiply this out. This multiplied is going to equal 15 root 5. Okay, and then we're going to take this and multiply these together. Now this is where you have to be very careful. You have a positive 3 times a negative 2, which is negative 6. And then you have root 5 times root 5. And we just said when you have a root times itself right here, if you have root 5 times root 5, that's just going to equal a 5. So we're going to have a negative 6 times 5. And that equals a negative 30. So let's put the pieces together that go together. 20 doesn't have a root, nor does the negative 30. So we put those together, we have negative 10. And then on the last part here, we put the roots together. We have 15 root 5s minus 8 root 5s. So 15 minus 8 is going to turn into a 7 root 5. And that's your final answer. Okay. Number 4. Oh, hang on. Number 4, we're going to be using the conjugate here. That's the key word here, conjugate. So the conjugate of root 2 is just to use root 2 again. This is only when we have a monomial. A monomial, remember, is when we have just one term, and that's all we have down here is just one term. Okay? So if we use the conjugate here, we're going to use that root 2. We use the same value. Multiply the top and the bottom by the same value. On the top, we have 20 times root 2. But on the bottom, we have root 2 times root 2, which we just talked about. Anything times itself is just going to be the 2. So we end up with the 20 over 2. That's going to come from this. The root 2 on the bottom, root 2 times root 2 is just 2. And then 20 on the top. And the root 2 that we had up here just gets carried down. And then we see if we can simplify. 20 over 2 is going to equal 10. And then the root 2 just comes down and stays a root 2. Okay. On to number 5. So this is a big problem, but remember, it's really easy if you think about it as a bunch of little problems, okay? Just again, recall, since we're dealing with perfect squares here, because these are square roots, let's see if we could break up each one of these one at a time. So the 700, when we look at it, can be broken into, look for one of the factors here. A lot of people might jump to 4, but you're not supposed to start with the smallest one. You actually remember start from the biggest number, and you work your way this direction, and then to this direction. So let's start with 100. 7 times 100 is 700, so we can break that up. The square root of 100 is just equal to 10, so we have 10 root 7. We're done with that part of the problem there. Okay, this is no longer anything we have to worry about. Let's just hold off on it. Let's move on to the 12 that's right here. 12 is going to be root 12 can be broken into which numbers on here? Well, the only one that works is our 4. So break this into a 4 and a 3. The square root of 4 is 2, and we're left with 2 root 3. Let's take the 63 and move on. If we look at the 63, the only factor that works over here is this 9. So we're going to break this into 63 divided by 9, which is 7. Square root of 9 is 3, and we still have the root 7. Root 3 is already just a prime number. It's already root 3. So we could just leave that as it is, as a root 3, which just gets carried through. So now we have to look at the parts that can be combined. Let's look at first the root 7s, okay? The 10 root 7 that's right here and the 3 root 7 have the same roots. So those can get put together. So if I have 10 root 7s and I add 3 more root 7s to it, I've got 13 root 7s. If I have a negative 2 root 3 and a negative root 3, what's going to happen is we have negative 2 root 3, because we have a negative 2 root 3, and then we have a negative 1 root 3. So if I have a negative 2 and a negative 1, I've got a negative 3 root 3. So put it all together, we've got 13 root 7 minus 3 root 3. Okay? All right, number 6. The difference between number 6 and the one above it is, remember, up above here, this is a monomial. There's only one term there. But when we look down at number 6, this is a binomial. There's one here and there's one here. So there's 2 terms, which makes it a binomial. We still use the conjugate here, okay? We're still going to use the conjugate. The conjugate of 2 plus 3 root 3 is to do, instead of a plus, we use a minus, okay? And we do the same thing on the top. The nice thing about the roots is that when we use the conjugates always cancel each other out, so we're just left with a nice clean number. Now this you could just throw right into your calculator, that bottom part there. But if you wanted to do it by hand, it's not too hard. You take the 2 and square it. You take the 3 and square it. And you take the root 3 times root 3, which is just 3. And because we have plus and minus going on in here, we're going to do subtraction. So this will be 4 minus 27, which gives us negative 23. Okay, and again, you can throw that directly into your calculator just to check the math on that. That's the nice thing about conjugates, is that the radicals go away. However, on the top, if we go through and we distribute this 5 out to everything, we'll have 5 times 2, which is 10, and 5 times 3, which is 15. So we have 10 and then negative 15, root 3. That will not simplify, it just stays as it is. So now one of the things that you might see, which is, I don't care either way if you do it, a lot of people don't like the negative down in the denominator. So what they do is they like to take the negative and pull it up to the top instead. And if we pull it up to the top, that negative will actually get distributed to the top, making it a negative 10 and then a positive 15 root 3. And then the positive, or the 23 turns into a positive. And that's it. That's all we can do. All right, let's take a look at number 7. So now we're dealing with variables. And remember with variables, what we're trying to do is we're trying to get them to go out in pairs together when we have a square root. This is a square root. There's a 2 here. It's just not written because it's called a square root. So let's start one thing at a time. Let's deal with the numbers first. Ready? Let's look at the 20. 20 can be divided into, using the 4 right here, 4 and 5. The square root of 4 is just 2, and the 5 stays inside. Your x to the 12th, let's look at this. So if we have 12 x's, how many pairs can go out? Well, 12 divided by 2 means that 6 pairs can go outside, and there's nothing remaining on this, okay? If we look at the y's, there's 5 y's. Excuse me. All right, we have 5 y's. So how many pairs can go out together? Well, this is one pair. This is another pair. So there's 2 pairs that can go out together, and there's 1 extra. So 2 pairs can go out together, and there's 1 extra that stays inside. That's it. Sorry, excuse me. All right, let's take a look at this one. So this one's a little different now. This one has a 3 in it, so we're looking for cube roots. So again, recall for your cube roots, if you can't remember the numbers, 2 times 2 times 2, 3 times 3 times 3, 4 times 4 times 4, and 5 times 5 times 5 will give us those values of a, I don't know what happened to my 5 on this one too, which gives us those values that we're looking for. All right, and we see if we can use those as factors to break up our 81. 81 is actually divisible by 27 right here. Okay, so if we break 81 into 27 and 3, the cube root of 27 is 3, and then we're still left with that 3 that was on the inside. Okay, looking at your 15, we're going to see how many groups of 3 can 15 go out as. So 15 divided by 3 gives us 5. 13 does not divide evenly by 3. Okay, we can't have even groups of 3 there. So what's going to happen is we're going to have 4 groups of 3, and there's going to be 1 remaining. So there's 4 groups of 3 with 1 remaining. That's it. One thing at a time there. All right, let's take a look at number 9. Okay, so when we see this now, there's multiplication going on, which we haven't seen yet. And when there's multiplication going on, the trick for this is to go through and actually multiply this out. If we see there's multiplication, multiply it out, and it usually simplifies pretty nicely, okay? So when we look at the coefficients, there's 128 here, but there's a 1 that's right here that's not written. So 128 times 1 is 128. With the x's, there's 5 x's here, and there's 7 over here. If I put those together, we're going to have, whoops, that's supposed to be a 12. Okay, so that's going to change my problem here. All right, I got a mistake on that, of course. All right, so let's fix this. That's going to be a 12, which is going to change this to be a 12. One little mistake causes a lot of mistakes throughout the problem, okay? All right, so there's 12 right there. Let's continue on, okay? And then for the y's, there's 2 here and there's 4 here, so there's a total of 6 in this problem, okay? So recall, when we're going to simplify, we're looking to see which numbers work with this 121. So again, we're going to start from this way and work our way down. Which value is the largest value that we can use that works with 128? So do 128 divided by each one of these, and the first one that works is going to be 64. So 128 divided by 64 is 2. We do the square root of 64, which is just 8, and then that 2 stays on the inside. The x to the 12th, we're going to have to fix this. This is going to be messed up here. Okay. When we look at 12, 12 is going to go out because we're dealing with square roots. We're going out in even pairs to 2. So 12 divided by 2 means that we have 6. Okay. With the y's, there's 6 y's. So when we divide this out, there's going to be 3 groups of 2. And then you have your answer. 8x to the 6th, y to the 3rd, square root of 2. All right, number 10. Looks like a lot, but again, it really is not a lot. The trick to doing this, again, is that when there's division, because we see division going on here, right? We see a big division problem, and we see multiplication. Put everything together if we can, okay? And let's see what happens. So I'm going to start first. Let's break this up so we can see what's happening here. 24 over 6, that's the stuff that's on the outside here, right? X to the 10 over x to the 4th, the stuff on the outside. Y to the 2, there's no other y's on the outside, okay? On the inside, we have this 32 divided by 2. Well, 32 over 2, let's just leave it like that for a moment. We have this x to the 10 over x, okay? And then y to the 14th over y to the 4th. So part by part, let's work through this and watch what happens here. 24 divided by 6, that just equals 4. 10x is on the top and 4 on the bottom. Who's going to win this battle? The top wins by 6, okay? The y to the 2 right here is just going to be y to 2. The 32 divided by 2 is just going to be 16. The x to the 10 over x, who wins the battle? X to the 10th on the top wins by 1, so there's going to be 9. Y to the 14th over y to the 4, who's going to win this battle? The top, that's going to be y to the 10. So there's all your parts now simplified. Now we just have to go through and break everything up. The stuff on the outside here, right here isn't going to change yet. We don't have anything to do with it at this moment, so we could just carry that down. It's ready to go for the next part of our problem. But let's break up each one of the inside parts. X to the 6, or square root of 16, I mean. What's the square root of 16? It's just 4. Okay. X to the 9th. So we have 9 x's. How many pairs can go out together? Well, there's 1 pair, 2 pairs, 3 pairs, 4 pairs, and so there's 1 extra remaining. So 4 pairs go outside and 1 extra remains on the inside. And then there's 10 y's, so those are going to be 5 that go outside. So we have that x on the inside, and now let's put all the stuff on the outside together that can go together. 4 times 4, 16. X to the 6th, x to the 4th is going to be x to the 10th. Y to the 2 and y to the 5th is going to be y to the 7th, and you're done. So it's not too bad if you learn how to break it down into those smaller little problems, okay? All right, let's take a look at number 11. So again, we're looking at cube roots, so be careful here. We're looking at cube roots. Cube roots means we're using those values that are right there, the 827, 64, and you can tell I just copy and pasted this table over and over and over because it's missing that 5 on every single one of these. All right, okay, so let's take a look at this. On the outside, not going to change it yet. That's going to stay exactly as it was. But on the inside, let's see if 24 breaks up into any of the numbers that's over here on this side, okay? The number that we can use here is 8. So 24 divided by 8 is 3. So we have 8 and 3. Then we have x to the 8th and y to the 5th. So on the outside, haven't done anything yet with it. It's still there, the negative 5, x to the 2nd, y to the 4th. But now let's go part by part. Cube root of 8. 2. Cube root of 3 stays as it is because we can't do anything with it. 8. Now what we're doing is we're going out into groups of 3, right? So if I've got 8 here, we're going to go into groups of 3. There's one group. There's another group. Okay. Oh gosh, hang on. I can't do it like this. All right. There's one group of 3 and there's another group of 3. So you can see that there's 2 extras remaining right here. Okay. So there's 2 groups of 3 that are going to go out, and there's 2 extras that stay inside. Okay. Look at the y's. There's 5 y's. One group of 3 can go out together. So there's one group of 3. And then there's going to be 2 remaining still on the inside. Okay? So the inside's done. We have 3x squared, y squared. Put the outside stuff together. We're going to have the -5 and the 2 will go together and be -10. We have x2 and x2, which is going to be x4. And then we have y4 and another y, which means we have y5. Okay? All right, take a look at this one. The trick for this one is, you notice how we have division going on here? Do the division. That's the trick. When there's division, do that first. So first things first, 54 divided by 2 is 27. X to the 15th over x to the 2nd is x to the 13th. Y to the 8th over y to the 6th, when we simplify that, is going to be y to the 2nd. We're doing square root this time, not cube root. So let's take a look here. Okay, which number works with that 27? It's 9. So 27 divided by 9 is 3. We still have the 13 and the y2. Okay, let's break this up into its parts. Square root of 9 is just 3. Square root of 3 stays square root of 3. 13, when we're going into pairs of 2, right? So 13 can go out 6 times as a pair, because that would be 12, with 1 extra remaining. So there's 6 with 1 extra. And then this 2, that 2 can go out as 1 pair, and it stays outside. And you're done. All right, take a look at number 13. So what we're trying to do is simplify this, recall the values, because we're dealing with square roots here, not cube roots. Okay, one problem at a time. Let's deal with this first here. Ready? Okay, so 4 root 80. We're not going to change the 4 yet, but let's look at the 80. Any of the values in our chart are going to work with this. The only one that works is 16. 18 divided by 16 works. We end up with 16 times 5. The 4 stays where it is. Square root of 16 is just going to equal 4. And then the square root of 5 stays square root of 5. 4 times 4 is 16. Square root of 5 stays square root of 5. And we are officially done with that part of the problem. This part right here is done. Let it be for a moment. Let's move on to the next part. 2 root 5. There's nothing you could do there. There's nothing. You're done. So you just carry it through until it's at the bottom, lined up with everything. Okay? So the next thing we're working on is this root of 45. Any of the numbers from my chart work with this? The correct answer is yes. It is 9. So 45 divided by 9 is 9 times 5. So 45 divided by 9 is 5. Square root of 9 is 3. Square root of 5 is just square root of 5. Bring that down, and this is where we're at. So now we have to look at this and say, well, is there anything that we could put together? All of these have the exact same roots, which means all of these can be put together. So if we look at the values, we have 16 plus 2, which is 18, minus 3, which is 15. So we have 15, and then everything has a root 5, so it's just root 5, 15 root 5. Okay? All right, this one's a little bit tough, but it's actually tough because it's just confusing for everybody initially. It's really not too bad. The rule for this is that if we're trying to rewrite as a radical, what we're trying to do is we're going to take this and rewrite it in radical form. So the rule is whatever your base is that we have here, the base in this case is 64. So whatever your base is, that's the base right here. And then we have a over b. We have a fraction going on here. To convert this to radical notation, you keep the base on the inside. And all you do is you do a divided by b. You put the a on the inside and then the b on the outside. Okay, so the a on the inside and the b on the outside. So that's the conversion. B goes on the outside, a goes on the inside, the base stays the base. So when we look at this value right here, that 64 is going to stay the base. Okay, that 64 stays the base. So if we're going to write this out, we're going to have 64 stay the base. We're going to have the root. And then what's going to happen is this value, which is on the bottom, goes on the outside. And then the 5 goes on the inside. Okay, and so this is our answer in radical form, cube root of 64 to the 5th power. Now, there's actually a way to do these by hand, or you can even just use your calculator. You don't have to do it by hand. You could just use your calculator, and you'll get the same answer. It all works out, in this case, to 1024. But how do we do it by hand? Well, 64 to the 5/3 power, there's a little trick for this. Okay, What we're trying to do is that 5/3 that's right there, we're trying to rewrite this 64 that's right here as a number that's to the third power. The reason we do that is we need these threes that are right here to work well together. So we want to use, this is the clue for this, if you're ever doing it by hand, is that 3 that's right there, we need to get a matching 3 right there. If there had been like a, let's say there was like a 2 right here, then we would want this to be a 2 right here so that they would cancel each other out. If it had been a 4 right here, then we would need this to be a 4 right here as well so that they would cancel each other out, okay? But I want a 3 there. And so what number to the third power is going to equal 64? Okay? And the answer for that is, when you think about it, it's a 4. 4 to the third power, because 4 times 4 times 4 is 64. And so what's going to happen is, now that these powers are working well together, we could take those 3's and actually cross them out, which is going to leave me with 4 to the 5th power. And 4 to the 5th power is 1024. Okay? But again, you could throw that in the calculator too. And then the last question here is an area problem. In this case, they're saying the area of a triangle, the area of a rectangle is, when you look at the formula, this value right here is the height, is the base, and then this part right here is the height. And so the formula is just base times height. So base in this case is 2 root 6, height is 15 root 8. Okay, let's go ahead and multiply these together. And since we're dealing with square roots, again, we've got our root chart there. Outsides get multiplied together, insides get multiplied together. 2 times 15 is 30. Root 6 times root 8 is root 48. The 30 just carries through, nothing we could do with it at this moment. The root 48, if we take a look at it, the value that's going to work with this is going to be 16. Okay, because 48 divided by 16 is 3. Okay, 30 stays as it is. Square root of 16 is 4. Square root of 3 stays root 3. Outsides get multiplied together. 40 times 3 is 120. And the root 3 stays as it is. And that's it. So as I said, if there's any part on this that you were not grasping because I went too quick, or something you just didn't understand, feel free to ask me. Go through this again and make sure that you understand it, because again, if you could do well in this, you're going to do pretty well in the assessment, okay? Until then, make sure you guys like and subscribe to my channel. Take care of each other, and be safe and be responsible, and have a good one.